We're inside ANSTO's Sydney campus, home to Australia's only nuclear reactor. And it's here that Professor Vanessa Peterson is gaining unrivaled insights into how energy materials function.
They form the working heart of devices such as batteries, fuel cells, and systems for the separation and storage of energy-relevant gases such as hydrogen.
She uses neutron beams produced by the reactor to gain real-time information about the material.
We need to look in great detail at them while they are working.
That's where instruments like Wombat come in handy. It's one of two neutron powder diffractometers housed here at ANSTO's Australian Centre for Neutron Scattering. Neutrons, which are subatomic particles with a range of energies, travel as a beam from the nuclear reactor to Wombat. The neutrons are then directed at whatever material Professor Peterson is studying. The way the neutrons are scattered by the material reveals information about it, right down to the atomic scale. For example, she can use Wombat to understand how the atoms within rechargeable battery components alter their arrangement as the battery changes its state of charge. Professor Peterson has developed approaches that make it possible to study energy materials within working devices, allowing her to understand the function of individual components within a complex system.
I've always been extremely driven to understand how things work in great detail.
Understanding that is helping to design better performing batteries, fuel cells, and energy systems. Professor Peterson's exceptional leadership and research make her a worthy recipient of the Nancy Millis Medal.
I love my job, and to any women looking to work in science, there is a place for you. Science is a broad church, and there are so many types of jobs and roles and ways in which you can contribute to science.